Okay, this is 5, 5. On this problem, I'm going to go ahead and draw what the cross section would look like. So let's get there we go. Draw a point. Come here, draw a circle. That's the outer diameter. Now we'll draw the inner diameter like this, and then we're going to just go ahead and label what the radiuses are. The outer radius and the inner radius. Outer radius here would be half of that, 1.25. Inner radius would be 1.15. Okay, so I'm going to slide this down here. Alright, the secret really to these problems is determine what the torque is going to be here at A and the torque is going to be at C. And what I recommend on these is just draw yourself a straight line representing the center of the shaft, like this, and then anything that's going to go this direction here will make positive. So what you're going to do is you're going to go straight up, and you're basically, it's just a sketch, going to come over. And this value would be your 600. Okay, then once you get to this point here, you go 350 back the other way. So all you're going to do is subtract 350 from 600. Get that straighter. And that will continue. We can draw a straight line today, let's see. Okay, so 600 minus 350, that's going to give me 250. And then you'll have 250 all the way from here all the way to get here. Now when you get here, 450 is going the same way as 350, so we'll subtract another 450. And 250 minus 450 would give me negative 200. Okay, so this is just a torque schematic of what's taking place on this shaft from this end all the way down to C. Alright, so now we're ready to solve the problem. We know that the shear stress of an object under torque is going to be the torque value times R. R, in this case, if I'm looking for the maximum torque, it will occur at the outer, so R will be 1.25. Divided by the polar moment inertia. And you just barely look this up. The equation for polar moment inertia of a hollow shaft is going to be pi over 2. And you have the outer radius to the 4th power minus the inner radius to the 4th power. Alright, so we can just say this very quickly, that the torque at A. Now A, if we look here, A is going to occur somewhere in here. Let's do that in red. A would be right in here. And let's go ahead and do B2. B would be over in this area here. So the torque that A feels is going to be the 250. So we took 250. Now this is in foot-pounds. We got to get back to inch-pounds. So I multiply that by 12 inches over 1 foot. Feet cancel out. Multiply that by the radius, max radius here, 1.25. Divide that by the polar moment inertia. And that's just going to be 1.25 to the 4th power minus 1.15 to the 4th power. You do that math right there, and you'll get the shear at A is about 3.45 kips. Okay, now it also asks you to draw what the shear stress would look like on a single element. So we're going to, you need to locate where the element is here. A here is on the side, I believe. Let's look here real quick. Yeah, let's see here. A is on the side. So we'll draw a rough little sketch. Let's see if I can draw something decent here. A square here. Square here behind, kind of like this. We'll draw a line, but connect these here. Okay, and again, A is located on the side there. So what A is going to feel is going to be sheared across that face. So the face would look something like, the shear would look like this. We'll just draw the arrows here. It's being sheared up because it's being sheared across the face here. Let me do that better. Come up. Now this one would have to come back this way here, and then the bottom would go back that way, like that, and then this one on the back side would come down. Because you're shearing across this upper face, that's why this arrow goes this way. Alright, now let's do what the shear stress will be at B. The shear at B, we go to the torque at B, which we said was 200. Don't worry about the negative because it just means go in the other direction. 200, and then we need to do conversion, so we'll just multiply this by 12 by 1.25 over the polar moment inertia of a hollow shaft. We run that value and we'll get 2.76 skips. Alright, so those are two values. Okay, now let's draw your shear element. What you have to do is just draw an element like this. Draw one kind of behind it, like this. We'll put the lines connecting them. Okay, and you are, since the torque we know is going this direction here, 200, we're going to be shearing across this front face. So we draw this arrow to go this way here. That means on the back side the arrow would go back this way here in the back. Then this across the front would come back this way, like this, and the back side of this one would come back this way. Move that out so you can see that. Like that. And that's what your shear element would look like. Alright, so this problem wasn't too bad. Alright, best of luck.